if I gave you a composite function, asked you to calculate the derivative, right? What's our derivative going to be? Yeah. So guess what we're doing? Now we're going to be able to undo this. So the question would be, how do you integrate this function, right? Obviously you're going to end up with the original but how do we get there? We get there with something called U substitution, right? So the key here is being able to recognize that there's a derivative in here, g and g prime, right? So this is the key, recognizing that relationship is involved. So if I give you something like this problem, you see that g and g prime of x, where are they? Yeah, g is here, the derivative is here, and we have a chain rule, and this would be f, right? So we have f of g of x and g prime of x, so the setup is there. That's key. So what we're going to do is we're going to substitute a U substitution, right? We're going to make this a U, so it's a single variable, and it's actually going to make this disappear for us. Actually kind of handy. So if I make U equal to x cubed, right? So now here's what I have. The sign is going to stay. Right? I've just substituted. How do I get rid of? So now look at this. I have to get rid of the dx because it's u, right? Those don't match anymore. And a 3x squared, all that has to be changed into terms of u. So how would I calculate a derivative of u with respect to x is what? Yeah, 3x squared, right? And then I'm going to move the dx over here. And it's just a simple math operation. So du is 3x squared. This is another substitution. I can eliminate these two items, right? And all I need to put here is a du. That's it. So I have two substitutions happening here. I've got the u, which I've declared originally, right? And then I do a derivative, and I get to cancel out the rest of the x's, or substitute the rest of the x's with a u as well. Okay. Is this a lot more simple than this one. Yeah, it is. What's the answer here? Plus some constant, because we don't have integral limits, right? We're going to talk about those Tuesday. Today we're just hanging out. Now finish your problem by resubstituting the u. So it'd be negative cosine of x cubed. Okay. And you notice all we end up with is f of g of x. This should be actually f prime. It was. Is that what you said? Yeah, that's not mathematically proper. You can't just make this poof. Tough the magic dragon's here. It's just gone. No, you know, there's some math behind that. It's almost like, yeah, in effect, that's what your end result is. Yes. So why can you do that? Because this is true. It works. Okay, so yeah, magic doesn't exist. Sorry. Let me show you a few more. If I vomited on the floor, it would look as pretty as that. Is that what you're saying? It's not. Again, okay, what's the derivative here? What's the derivative of this? 2x, right? We have an x here. The 2 we can deal with. Okay, but the x is there. That's what's key. Right? So what do we want to select as our u value? Do we want to pick x squared plus 9, or do we want to pick x? Why do you want to pick x? Okay. I'm going to go with it. What's the derivative of x? Right? Okay, so multiply over. You'll get to the point where you're actually skipping this step right here. Okay. I did what you told me to do. Because I did what you guys told me to. This is not a part of the problem. So okay, is that any easier? Okay, so we picked the wrong u value, right? No big deal. Okay, I'm going to actually rewrite that. Okay, you did this on an exam. Oops, right? Are you going to spend time erasing it? No, you're going to do this. And they won't even look at it. Okay? Don't spend the time erasing it. Just cross it out and move on with life. So let's pick a different u value. What do you want u to be now? So the derivative is we'll deal with that here in a minute. Okay, right? Well, let's you'll see how the fifth power is. So we got u in here, correct? Okay. Does this match that exactly? No. What can we do to make them match perfectly? Divide by 2 here, yeah? So if we're going to divide by 2, 1/2 du is x dx. Now it matches, right? So I have a half and a du. No, the x is gone. We've got rid of the x and the dx are gone, and du, half du is in its place. Is this a lot more user-friendly? Again, your point here is to get these to a spot where you can calculate the integral. So let's see, antiderivative of u to the fifth. And then resubstitute u back in. You got your integral. Let's try. Off the top of my head, I'd have to go look at my data.
How much do I really need to know this about? He's not even
Try this one on your own, and I will come around and help. Okay, so try that on your own. Pick a u value, substitute it, calculate the derivative, resubstitute. See something on that problem that has to do with derivative. Set u equals. Yeah, but you've already used it as your u. So is there a function in here that has its own derivative? X squared has a derivative 2x, right? So this is our u value. There's always something you're going to leave alone. On the last problem, it was the fifth power. On the first problem, it was sine. Here, it's the e. U is x squared, and it's going to get rid of this 2x. A lot of good work now. That's not what I wanted to write. Where? Here? What do you mean? Oh. You mean like the first one I showed you? Right, because that's the antiderivative of sine is negative cosine. Yeah, you still did it. It's just masked. Well, when you integrate, right? So if I just say I gave you this problem, right? Very straightforward power rule. It's x cubed over 3. Plus c. When you calculate it, it would be whatever. So, there you go. Anything else? Again, starting slow. All odds. Okay. A. This is an A. Okay. Check your answers in the back of the book.
That's 110.
Yeah. 1 through 110, along with number 17. Twice. Yeah. It's 1 through 11 odd. Give it your best shot. This just follow that method. Something with a derivative. That's what you're looking for. Okay.